For this video, we're going to talk about multimeters and their important uses. A multimeter, like this one here, can measure the voltage of different components and what's running through them, or their voltage drops, uh, the resistance of components, and their current, as well as if a wire is continuous or not, or if there's a break in the circuit. So what you do is you have a multimeter like this, and you see there's three different places. You have 10 amp, the VQMA, which is actually the connection that's fused with a 250 milliamp fuse, and the common ground. So you get your black, you put it into your common ground, you get your red, and for most of the time, you'd want to use the 250 milliamp fuse. You only use the 10 amp if you're going to measure the current of a device that's drawing more than 250 milliamps of current. And then here you have your different settings. You have DC voltage, AC voltage, your current, your 10 amp fuse, your resistance, and your continuity, as well as voltage of batteries. So for this video, we're going to test voltage of batteries. So I'll use this side here just to measure most of the stuff. You can see 600, 220, 200 millivolts, and 2000 millivolts, or 2 volts, and 200 millivolts. So since these right here I'll be testing are 9-volt batteries, we're gonna go 10 and 20. This means that this is the max value that the voltmeter will read. So 600 being the maximum is 600, 20 being 20. So I'm gonna put that 20. So for this one, let's use this battery here. So I'm gonna get the other leads. I'm gonna connect them positive and negative. So like so. If you're gonna short circuit the battery. And this one here reads about 7.42 volts. This one right here will read about 8.9. So this is almost fully charged, while this one's kind of drained out. Wait, now you should do the current and resistance as well, huh?
Yep.
For this video, we're going to talk about multimeters and their uses. This right here is a multimeter. It can measure voltage, resistance, and the current of a circuit, as well as finding out the continuity, if there's a breaking circuit or not, and also measuring AC voltage if you need to. So let's get started. First, you'll notice that almost every multimeter that you'll encounter has three different inputs here. We have the 10 amp, a VQMA, and a COM. This is for the 10 amp fuse. That's for high current loads up to 10 amps. If you're going to be measuring current, the 10 amp fuse. The VQMA, which is fused with a 200 about a 250 millivolt fuse or milliamp, sorry. Let's try it again. Video, we're going to be talking about multimeters and their uses. This is a multimeter and it can measure the voltage, the resistance, and the current of a circuit, as well as the voltage of an AC circuit, as well as if the circuit has a break in it or not. So most multimeters have 3 inputs, and 10 amp, a VQMA, and a COM. The 10 amp is for the 10 amp fuse. That's for high current loads up to 10 amps. If you need to measure that high current, the VQMA, which is actually the most commonly used input, that's for most circuits that have a current draw about less than or around 250 milliamps, and the COM, which is the common ground. So to measure voltage, current, and resistance of a circuit, you would get your leads, which are either these banana plugs and or other sockets that would go into this. And you put the black one into the common ground, and then the red one into VQMA for power. And then let's get a circuit. This right here is a sample LED circuit. It has a 5 volt. We know it's 5 volts because of our power supply here, but let's say we don't know. So we turn the circuit on and lights up. We have a random resistor in there. We have an LED. We don't know what current, what voltage, or anything else that the circuit has. So let's first measure the voltage across the LED. So let's get our multimeter right here. And let's go to 20. These numbers mean the maximum that the multimeter will read. Also, it sets how precise the voltage or the value is going to be. So for smaller numbers of voltage, it has a higher precision in the decimals. Because our circuit here is about 5 volts, we only use 20. But let's say you don't know and you chose 200 millivolts. Then if you measure the circuit, putting the positive lead in the positive side and the negative lead in the negative side, here, you'll see that it's about what it says 1. 1 means that the value is greater than the highest value possible. So we're going to go up 1. And then let's read this again without shorting anything out. And it reads about 3 or 2, depending on what lights are on. Now, if you chose your value to be really, really high, say you chose 200 volts instead, and you were to put this back on, you can see that the voltage will say it'll still have it there, but it's at a less precise value. And then you go really, really high, it'll say 0, which usually means that you're too high. So let's measure resistance now. For resistance, you turn off your power supply, and you choose about, let's say, 20K for our first one. 1 means that, again, your value is too low in this case. So let's go, or your current state here is too high. So let's put this around the LED, and you see 2.51. It says you can go, since it's above 2000. If you go on 2000, it'll say 1. So this LED has about 2.51 kilo ohm resistance. And then for measuring current, we have to break a circuit. So let's first choose the highest value. Never go for the lowest value. Always start off with the highest, or else you will pop the fuse in the multimeter and then you have to replace it. So start off with 200 milliamps. And then you'd break the circuit. So put it in series, and then put your alligator clip here and turn on your device. So this is about 2 amps or so. So since it's less than 200, we could go down to 20. And I'll show you a more accurate reading, but you can't go down to 200 micro because that's way too high. So for a 250 milliamp fuse, you can only hold it for about, well, you can usually use it forever, but the 10 amp fuse can only hold 10 amps for about 10 seconds before it pops. And if you want to check the break, and this is a break, so you just say this is back to, circuit here, onto the, so right now it won't make a sound, but if you see, if the circuit's not broken, if it's a closed circuit, it'll beep. I don't know if you can hear it, but you'll see a low resistance. So putting this between the LED, that's a really high resistance value. But if we were to go from, let's say, the resistor out here, it should show a different, I can't really reach there. Yeah, that's the resistance of the actual resistor. All right, thank you. I feel like this is